The cold metallic interior of a microwave lacks traditional thermal heating elements. Heat is generated instead by a concentrated burst of pulsating energy. Agitating water molecules requires high-voltage electricity converted into 2450 MHz radio waves. Tracing the path of this energy, from the wall outlet to the food, explains how this process creates heat almost instantly. Standard 230-volt power is the starting point, but it must be channeled through the high-voltage transformer and capacitor shown here. This increased voltage powers the magnetron, the core generator positioned directly above the electrical supply. The magnetron emits a continuous stream of electromagnetic waves at 2450 MHz, with a physical wavelength measuring 12.24 centimeters. These waves are channeled into the cooking cavity through a waveguide, preventing the energy from dispersing randomly. The stainless steel walls reflect these waves, creating a concentrated environment where electromagnetic energy bounces continuously throughout the chamber. Microwaves do not penetrate to the center of food. As this diagram shows, they are fully absorbed within the first 2 to 4 centimeters. As waves pass through this outer zone, they force water molecules to vibrate rapidly. The microwaves themselves are not hot. The immediate heat rise is the result of intense friction between these vibrating molecules. To address this limited penetration depth, a motor-driven turntable constantly rotates the food to ensure even exposure. Because heat production is restricted to the surface layers, the system relies on physical rotation to prevent cold spots in the food's interior. This unified system generates heat directly within the food, wasting less energy than traditional appliances that heat ambient air. Effective operation requires the presence of water molecules to absorb the generated waves. Running the appliance empty forces the magnetron to absorb its own reflected energy, which can cause internal damage and permanent failure.